nuclear fission reaction. And we already talked about this, that nuclear fission reaction is called as chain reaction. Why this is a chain reaction? Because it started with one neutron, and then one neutron gives you three further neutrons. And this way the reaction started, and it goes on and on and on and on, right? So when it goes on and on and on, definitely this reaction will start it and will not stop. Okay. That type of reaction in which you initiate with one thing and then it will continue, that type of reaction is called as chain reaction. So only one extra neutron is required to induce the uranium-235 nucleus to split by fission. During the fission, it produces two or three neutrons, which moves away at right speed, and each of these neutrons can start another fission reaction, which again creates further excess neutron. This process is called as chain reaction. So I want you to put a heading of chain reaction now and write this definition, please. Ibrahim, Yumna, Armina.
Yes, I'm done.
Okay, still right. Please write it quickly.
So I'm done.
Okay, Ibrahim.
Yes, I'm done.
Okay. Now this is the actually reaction which is happening here. We called it fission reaction. Now if you check this out, this reaction is started with one neutron, right? And then this one neutron leads to two, three neutron every time. And definitely they further go into the further nuclei. And this reaction once started will not stop at any cost. Then that's what we called as chain reaction. Now check this one out. They're saying it is the neutron hitting the uranium-235 nuclei which cause the fission reaction. The daughter nuclei do not need to show. Okay. So this is what we have it. Now let's talk about the diagram here. And I do not want you to draw this diagram. I just want you to draw diagram till that point. I just want you to draw this box. That box only. That's it. There is no need to draw this box. Can you draw that quickly? And then we will see what exactly they are. How are you, Safiullah? Assalamu alaikum.
Walaikum salam. I'm good, sir. How are you?
I'm good, good. Safiullah, I want them to draw this diagram. I want you to draw this diagram as well. This is called
Oh,
nuclear reactor, and we will discuss this later on. But first, I want you to draw the diagram, the box which I just marked. Do not need to draw this.
okay.
Only this box.
Okay.
Label it as per the diagram is saying.
Sir, I'm done.
You're done as well. Okay. Yamna, what about you, beta?
Yeah, I'm done.
Okay. Now I want you to write few lines. In a nuclear reactor, a chain reaction is required. A chain reaction is required. A chain reaction is required to keep the reactor running. To keep the reactor running. Second bullet point, when the reactor is producing energy, when the reactor is producing energy, two factors must be controlled. When the reactor is producing energy at a constant, at a correct rate, two factors must be controlled. Number one, the number of free neutrons in the reactor. Number two, energy of free neutrons. Energy of free neutrons. Now, what does it mean actually? Let's talk about this first and then we will write it further. The first thing first, if you see this nuclear reactor, you see that it's covered up with a radiation shielding. Now, this is made of lead so that all the person or the people who are working in a nuclear reactor position, they are safe from the radiation coming out from the nuclear, from the radioactive elements. So this is the radiation shielding for that. Pressure vessel means definitely we need a pressure condition there, so that definitely it will work out for us. What do you think a control rod means? Yes, who will tell me how to control this reaction? If you do not want this reaction to be going uncontrolled, you need to control the number of neutrons which are coming out. So this control rod will do a work of absorbing the neutrons. If you absorb the neutron further, this reaction can be easily controlled. So if you control the neutron as per requirement, you can use this reactor to produce energy, and that's the further circuit which is there here. It is used to produce electricity if you check it out. So this reaction, which is outside this nuclear reactor, this reaction is further reaction is used to produce electricity from that. But remember that if this reaction is out of order, or you can say out of control, you cannot produce electricity, but it produces too much energy that will actually damage each and everything. That's the reason we called it atomic bomb. Then this reaction will be used to make atomic bombs. So this control rod means this is a rod made of such an element that absorb neutrons into that. Then you can see graphite moderator. Here in this plate, graphite moderator is a sort of a substance which actually reduces the speed of neutron such a way so that kinetic energy of the neutrons will be reduced, right? So that it won't go very fast. The third thing is called fuel rods. Fuel rods are made of uranium. That is what we called as fuel rods. All right. So now, first heading, control rods. Put a heading of control rods, and I'll dictate you what to write here. You do not have to write everything. First heading, purpose of the control rods. Purpose of the control rods. The purpose is to just write it down. The purpose of the rods are to absorb. The purpose is to absorb neutron. Second bullet point. Control rods are made of. Control rods are made of material which absorb. Control rods are made of material which absorb neutrons without becoming dangerously unstable themselves. Without becoming dangerously unstable themselves. Next bullet point. The number of neutrons absorbed is controlled by varying the depth of control rods, varying the depth of the control rods in the fuel rods. Lowering the rod further decreases the rate of fission as more neutrons are absorbed. More neutrons are absorbed. Second bullet point, raising the rods increases the rate of fission as fewer neutrons are absorbed. Students, any problem? What exactly they do? Very simple case. If you want to reduce the rate, you can move it down. I mean, you can put the rod a bit down, these rods. Or if you want this reaction to be a bit faster, then you can lift the rods. Because as you move it down, lower them down, they will absorb neutron. And if you want less neutrons to be absorbed, you have to raise it. Any question regarding this? Okay, now on the next. Moderator. Put a heading, moderator. The purpose of moderator. Then put a heading. To slow down neutrons. Now write the bullet points. The moderator is a material that surrounds the fuel rods and control rods inside the reactor core. Inside the reactor core. Next bullet point. The moderator is a material. The moderator is a material that surrounds the fuel rod, that surrounds the fuel rods and control rods inside the reactor core. Next bullet point. Fast moving neutrons produced by the fission reaction, fast moving neutrons produced by the fission reaction, slow down by colliding with the molecules of the moderator of the moderator, causing them to lose some momentum. Next bullet point. The neutrons are slowed down. The neutrons are slowed down so that they are in thermal equilibrium. They are in thermal equilibrium with the moderator. Hence the term thermal neutron. Hence the term thermal neutron. This ensures neutron can react efficiently with the uranium fuel. This ensures neutron can react efficiently with the uranium fuel. Put a heading shielding.
Sir, hello.
Yes.
What is thermal equilibrium?
I will explain. First write it. A thermal equilibrium is actually a position in which you do not have enough energy for neutron that will actually damage your system, right? So actually what happened, the energy which is given to them will be equivalent to the energy it has. So neutrons are slowed down so that they are in thermal equilibrium. Because what happened, when too many neutrons are coming out, suddenly the energy inside the nuclear reactor increases. Am I right? Yes, Ibrahim.
Yes.
So what happened, when you slow them down, and you will slow them down to a certain level that the energy provided and energy release will be same, that position is called as thermal equilibrium. So energy inside and energy outside will be same in that condition. Or you can say the energy provided to that system, nuclear reactor, and energy released by the nuclear reactor. If both are same, we give it a name called thermal equilibrium. Okay. Now put a heading shielding. Write this please, all, and see if there is any problem, let me know. The entire nuclear reactor is surrounded by the shielding material. The purpose of shielding is to absorb hazardous radiations. The daughter nuclei formed during fission and neutron emitted are radioactive. The reactor is surrounded by steel and concrete with that can be nearly 2 meters thick. This absorbs the emission from the reaction and that ensures that the environment around the reactor is safe. I want you to draw this diagram as well. Okay.
Yes, sir.
What about others? Okay, that was the last topic of this chapter. In the next class, inshallah, we will start with magnetism. Okay, so be ready for that. Okay, students, did you copy?
Yes.
Okay, then we'll finish this topic. Okay, so inshallah, in the next class, we will start with magnetism. So see you guys. Bye then. Allah Hafiz.